Hey guys, and welcome back to a new video. Did you ever have to work with a shitty API design as a mobile developer? Because very often APIs are designed for web development. But in the end, we mobile developers also have to work with APIs, and that often face problems and inconsistencies in the JSON schema. That's at least an issue that I faced when building my recent book app with a composed multi-platform. So if you watched that free course here on YouTube, which I'll also link somewhere up here, then you will know this problem already. But I think this really is something that is worth condensing into a single video, because this problem really happens more often than you think. So what is the problem? We do have an API here, the Open Library API, which itself is great because it just provides free data on all kinds of books, and it has this works endpoint where we can fetch book information, book details for a specific book that has an ID in this form. So far, so good. You can see I have two of these endpoints open here. On the one hand for this book, which is the 48 Laws of Power, and we were interested in this description field in this book app course. You can see the description here is really just a normal string. Super easy to work with that. But if we now take a look at a different endpoint, like same endpoint but different book, just a different book ID here, and here suddenly the description is a JSON object and not a string anymore. And if you work with JavaScript, then parsing that is relatively easy. But in a mobile environment, we typically work with type safety. We work with these JSON parsers where we have our Kotlin representation of this JSON structure, where we have to say the description is actually this specific type of class or field. So it has to be a string, or it has to be an object. But if the endpoint sometimes responds with an object and sometimes responds with a string, then by default, our app would not be able to handle that with Kotlinx serialization, which is nowadays typically the library we use on Android to parse JSON data. So that is what I want to show you in this video, how we can build a custom serializer to handle scenarios like this. So for that, I've really prepared a blank Android Studio project. The only thing that I have included is the Kotlinx serialization library and Ktor. So Ktor is our network client, which we'll use to just execute a dummy request to this Open Library API, one request to the endpoint that returns the description as a JSON object, and one request to the endpoint that returns it as a string. And then we will parse this JSON response here to a Kotlin data class with Kotlinx serialization. I've also already added all these dependencies here to build.gradle. So feel free to just copy paste that from the GitHub repository in this description as well. I think I might have forgot. No, I actually also added the Gradle plugin here. So the first thing, when we want to parse something from JSON into a Kotlin data class, the first thing we need to do is we need to declare the representation. We need to declare that data class we want to parse something into. So let's create that class. Let's call this book work DTO. So DTO stands for data transfer object, really just that Kotlin representation of a JSON model in this case that I talked about. This would be a data class. And all we care about here for our use case is this description. You can of course also extend this with more fields if you need more fields from that response that I just showed you. But for this example, let's stick to the description here, because that is the challenge here, since the API sometimes responds with a JSON object, sometimes with a string. Whenever we want to parse a JSON response into a Kotlin data class here, with Kotlin serialization, we need to annotate this with serializable as well. And if we now actually take our two endpoints here, on the one hand, this one, where the description is responded with as a JSON object, and we just execute this here in main activity, this is really just for demonstration purposes, what this would do. We have a lifecycle scope, so we have a coroutine. We launch this here. We say val JSON object endpoint, let's call it like that. Paste this in here, and we also have one for string endpoint, so where the description is returned as a string. Let's also quickly copy paste this here, really just the ID that differs. Put this in here, and now we want to fetch the book data from each of these endpoints and get the description from that JSON. So what we can do is we can say we have a list of the let's start with a string endpoint and the JSON object endpoint, and then we can iterate over these two URLs and execute a request with these. For that, we can also create a quick dummy HTTP client, which is equal to HTTP client. We make use of the OK HTTP engine from Ktor, just like that. So again, normally in a project, I would create this in a factory or so, and then provide this dependency with a proper dependency injection setup. But here, the focus of this video really lies on the serializer that we will implement in a moment. First of all, I want to show you the problem. So here in this HTTP client, what we can do is we can install a plugin from Ktor. On the one hand, call logging, for example. No, I actually didn't include that. Was it just logging? No. And that also doesn't matter. because we don't need to see the call stack and the call logs. But what we definitely do need is content negotiation, since that is the plugin that allows our network client to automatically parse the JSON response into our data class. And here we need to kind of link this to Kotlin serialization, which we do with JSON. We can then say our JSON object is equal to JSON. I think we can open this like this. Apparently it's not available. Did I miss a dependency here? Okay, I looked into it. Apparently it was just a version mismatch, because I was thinking that we can use the Kotlin version for Kotlinx serialization, but it seems like we need to declare our own version, which is currently 1.7.3. But if you got the code and the dependencies from GitHub, then you will already have that. So then this is actually recognized, and we can create our JSON instance here. And we just want to set ignore unknown keys to true. So that means that our JSON parsing won't crash if there are unknown fields. So if there are more fields contained in the JSON response that we declared here in our DTO, we want to parse that into. But that should really be enough for now. We have an HTTP client we can now use to make the request. We can say HTTP client.get, it's a GET request, where we just specify our URL string, and that is just the URL we get here in the for loop. So we just make one request for each endpoint. We then do get a response from that, and we can then parse this. So the actual DTO would be response.body, and we want to parse that into a book work DTO. And then we can say book description is DTO description. We should also remember to add internet connection here in our manifest. Up here with the user's permission tag, internet. And then we can already test this, but obviously it won't work yet. That's probably what you can already guess. You can take a look here on my running devices, not this one, but this one, please. And then also take a look here in our logcat, filter for book description. Okay, Gradle complains because we're not using target SDK of 35 and compile SDK. Let's quickly update these two. It's still crazy that the default setup of Android Studio comes with a compile issue. There we go, the app is now launching, and now it's crashing because of exactly that issue that I've explained. So you can see, on the one hand, it prints this book description, which is the one where the description field is actually a string, because for that, Kotlinx serialization knows how to parse that into the string field. But for the second field, you can see it complains that the description field is actually an object. And obviously, we still want to parse that description that is actually hidden in this value attribute if description is an object. So how do we do that? We create a custom serializer, as I already said. But the way this works is that is really just a plain Kotlin class, or an object rather, and we say that is a book work DTO serializer. Since these types of objects, we want to serialize and deserialize with that. And that will be of type K serializer. So from Kotlinx serialization needs to contain a certain type, and that is the type that we want to serialize or deserialize. So our book work DTO. And you can see we do need to implement certain functions here, which you can do. So deserialize, the descriptor, and serialize. If we click OK, then these will be added. Let's go through these step by step, what we need to do for these functions. On the one hand, we have this descriptor, which is really just a descriptor that outlines which specific fields of that JSON response we now want to consider parsing. So it's really just for us to tell the serializer, these are the fields we care about. And we can easily just set this equal to build class serial descriptor. To build such a descriptor, we need to pass in the actual serial name, so the name of our class. So the serial name, that will be book work DTO ;class, that simple name. And we can make sure that this is not null, because our class name certainly exists. And then we can open this block of code, this lambda expression here, where we can specify those elements. So one element is really just equivalent to one field of our JSON response that we care about. So here, an element would be our description, for example, or it would be the authors. It would be the first published date. So for all of these fields that we now care about in the response for this book work DTO, we would specify one of these elements here, and we specify it in the type that we want to have it. So this would be a nullable string here, and we call it description. Because in the end, the description is really just a string. We don't care about this type-specific information that we would get from this other endpoint here, You can see when it's an object, it also contains information about the type, that it's a text. Well, thank you, Sherlock, but we just want the value in that case, which again is just a string, but it is in a different field name. That is why we need this serializer. So here we really just care about the description. If you would care about other fields as well, you would just have more elements here specifying which you care about. Then we have a deserialize function, which gives us this decoder. So this decoder now allows us to get access to the JSON response step by step, and then deserialize that. So the JSON response is considered the serialized response, since JSON is really just a unified format that allows us to exchange data over the network, which all different platforms stick to, which all different platforms can understand. But now when we deserialize that serialized format, then we want to bring it back into a format that is better to work with for our specific platform. So a Kotlin data class. So here comes the logic, our conditional logic now, where we say, okay, if our description is actually just a plain string, well, then it's easy, then just take that plain string. But if it's an object, then we first need to deserialize that object before we can then extract the other field name, the value field, which contains that description. And then we have a serialize function, which is relevant if we actually have such a book work DTO and we need to send that to the API. So we need to take our Kotlin class and serialize it to JSON. The deserialize one will be the more difficult function here, especially if you just need to fetch data from an API, like in our case. We won't make use of the serialize function, but I will, of course, still explain how it would look like. And in the end, we definitely want to have some sort of description field here in this deserialize function, where we can then return our book work DTO at the end with our description. And in between here, we want some magic to happen based on this decoder, which allows us to iterate over this JSON structure and then conditionally deserialize the description field so we can assign the correct description value here. And the way this works is we make use of this decoder and we say decoder, that decode structure, where we pass in our descriptor. We just want to decode the structure, the JSON structure here, and we use our serial descriptor that we've declared up here. So we kind of tell this decoder the schema we are trying to serialize or deserialize here. And then here, where we want to perform the magic, we just want to have a while true loop, which would be necessary if we would have multiple fields here in the JSON response that we would want to parse and deserialize. In our case, we just have one, so this wouldn't be strictly needed, but normally you will have more of these fields that you also want to include in this book work DTO. So we just want to iterate over all fields. And then we can check when val index is equal to decode element index, where we again have to pass in our descriptor. And this index will now correspond to the index or the position of the field that is currently parsed based on the serial descriptor. So in our case, we just have one element here, one string. So the index can only be 0. So this would be element 0. If you would also want to parse the title, for example, here, then the title would have the index 1. So then the index could be both 0 and 1 in this case, where you can then check, okay, if the index is 0, that means we are currently deserializing this description, since it's the 0th index here in our descriptor. If the index is 1, that means, okay, the deserializer is currently deserializing the title. So our logic to decode that title comes in here. And if the index is composite decoder.decode done, so that's just an integer code that is returned from this deserializer when it's done decoding, when there are no more JSON fields to be deserialized. So in that case, we just want to break out of our loop since we say, we're done. If it's something else, then we can throw a serialization exception, since that means we found some kind of invalid index. So we can actually remove this one here since we don't care about the title. That was really just an example how that would work. But if this code now triggers, that means, okay, we found this description field, but we did not deserialize it yet, because now needs to come our conditional logic where we check, okay, is that field actually a JSON object, which we would first of all need to deserialize again in order to extract that value field. So checking that again. If this field is a JSON object, like this one here with these curly braces, then we need to deserialize that into a data class first of all, and then actually assign the value of that field to our actual description. If it's a string, then we can just use that string field right away. So what we need is we need a JSON decoder, which we can get in here from decoder that is from this, that comes from this parameter here. And we want to try to parse that into a JSON decoder. If that's not a JSON decoder, that means we are not we're not dealing with the JSON data here, so this should also throw an exception. This serializer only works with JSON, something like that. What we then want to do with this decoder is want to decode the current element, so our description, since we're working with the index 0. So we can say JSON decoder, decode JSON element. And a JSON element is really just the value of a JSON field, but it contains information about what type of JSON value that is. So is it a JSON object? Is it just a primitive, so a string, an integer or so? Is it maybe a list? So that is now what this JSON element contains. And we can then say, we take our description and we conditionally assign the value of it based on what our element is, based on what the type of our current element is. So if the element is a JSON object is something that starts with these curly braces here, which consists of possibly multiple such JSON fields. If that is a JSON object, we first need to take this JSON object and parse it into a Kotlin data class again. So let's come up with that Kotlin data class, which we can call description DTO, which really just stands for the description JSON object that we now try to deserialize. So this would be serializable again. And the value, the field name of that description is called value. So this is now the Kotlin representation of exactly this object that we have here. We don't care about the type, so we don't need to include that in our data class, but we do care about the value. So we need to use the same name here in Kotlin. And then in here, if we are dealing with a JSON object and we know that this JSON object has the structure that I just showed you, then we can say decoder.json, that is the JSON instance, which allows us to deserialize something, decode from JSON element, because we are dealing with a JSON element here, where the element is just our element, and the deserializer, that's really just our description DTO, that's serializer. So this is just something that is provided as soon as we annotate something with serializable. So this, if we have over here, found a unit, so apparently this returns unit, maybe we need to specify that we are decoding this into a description DTO. That's probably unit because we don't yet have the else branch, but the type is inferred here. But what's important is that this now returns this description DTO, and since we want to assign the actual string description to our description field, we don't want to assign this DTO, but rather refer to its value. So we can say that value. Else if actually, if that element is now a JSON primitive, so it's a string, integer, float, boolean, some kind of primitive value, and that element is actually a string, then we know that we can parse it directly. So then we can assign just our element.content. So this will really be the raw content of that JSON field, so or description if it's just a string. And all other cases, so if it would be an integer, for example, then we just assign null, because then we can't really parse it. And then down here, we actually need to change this return to return at decode structure, and the description here, well, is nullable. Let's also make it nullable here in our book work DTO. And then we don't have any more issues here. So this is how deserializing that works. Serializing is, in this case, much easier. So this would now be relevant if the API would offer maybe an endpoint for you to also push some kind of book data to that API, where you need to take such a book work DTO, construct this in your Kotlin code, and then send this data as JSON to the API. And this, of course, now depends on the specific format that the API would expect here the book work DTO to be in. This is the logic you would need to encode here. For simplicity, what we can say is we will just always attach the description as a string. But apparently the API has some kind of different logic here, because sometimes the description is not a string, but it is an object with more information. So we would need to know more about the exact logic behind that decision, which kind of serialization format we stick to here. But all we can do here is we can say encoder, so that's now the opposite of the decoder, that takes an existing value, book work DTO, and encodes that to JSON. So encoder encode structure with our descriptor this time, like this. And here we really just want to say we take the value description .let, and then we can say we encode that string element, so it's a string, pass in our descriptor. The index we want to encode this into is 0, so this again has to match this index here of this element. And lastly, the value of this will be it, so the description. And that's really everything we can do here for serializing this. As I said, not necessary in our case, but in certain scenarios, you also want to serialize this back to JSON. And this is now how this works. This is how you tell the serializer to consider this. Okay, so we now have the serializer, but we did not really make use of this yet. You can see it's grayed out, it's unused. So how can we tell this book work.to that we want to use this specific custom serializer just for this book work.to specifically? That works by going to this annotation and saying with and specifying this book work.to serializer with a double colon class. And if we then go back to main activity where we have our HTTP requests prepared and we launch this, take a look in Logcat and we clear this up here, then wait a moment. And now you can see it actually fetches the description for both books. This is probably cut off because we have the filter here. Yes, so it has one print line statement apparently for every line in this Harry Potter description, but it is complete if we remove the filter. So because even though those two books have now different JSON field schemas, we can still parse these in a unified way. So ideally, the API design is, of course, consistent and was also made to make the life of us mobile developers easier, but that's not always the case. You'll always face situations in the real world where you just have to work around certain situations, work around certain weird requirements or such schemas. That's part of the game, but this is how you can do it. And I'm pretty sure over time you've also experienced such situations before, or you're like, okay, I have a very specific problem here that is based on my specific API, maybe on my specific database, and you really struggle to get help with that, to find about a consistent answer online. Then you might want to check out my mobile dev campus, which I'll link down below. So it's really a place where mobile developers come together, learn together, where you can participate at coding challenges, where you can actually win money for learning coding and just get help for all your issues. So I'll link that down below. It's described how that works, so check it out. And I can only say thanks for watching this video. I will see you back in the next one. Have an amazing rest of your week. Bye bye.